In the last lesson, we learned if we were multiplying powers with the same base, we added the exponents. And in this lesson, now we're going to divide powers with the same base, which you might have guessed that we are going to subtract the exponents. So in number one, there's many different ways that you can do this. So you can either do it like so. Since these have the same base, then we take our 3, we subtract our exponents, so I have a 6 minus an 8, which gives me a 3 to the negative second power. And since it's a negative second power, I need to drop it down into the denominator, which would mean that I'm left with a 1 in my numerator, so I have a 1 over 3 to the positive second power, which gives me a 1/9. That's the long way of doing things. Another way that you can do this is you see which exponent is the largest, which the 1 in my denominator has the largest exponent. So what we're going to do is we're going to keep the 3 in the denominator with the largest exponent, and we take my largest exponent minus my smaller exponent, so I have an 8 minus a 6, which leaves me with a 1 over 3 to the positive second power, which still gives me the 1/9. So it's up to you how you want to do this, but I'm going to show you the shorter ways. So number 2, which exponent is the largest, a 3 or a -2? A 3 is the larger exponent. So my x is going to stay in the numerator, and I'm going to take my exponent of 3 and subtract my smaller exponent from it, which is a -2. And a 3 minus a -2 is really a 3 plus a 2, so I get an x to the 5th power, and that is my answer. All right, my next one. For the x's, my exponent that's larger is in the numerator. So my x will stay in the numerator, and I take the larger minus the smaller exponent over, for my y's, my larger exponent is in the denominator, so my y will go in the denominator, and I do my larger exponent minus my smaller exponent. So I wind up with an x to the 7 minus second is the 5th power over a y, and 5 minus 3 is the 2nd power. And that is it. All right. And then now we're going to raise a quotient to a power, just like in my last lesson, how I raised I raised a product to a power. So same thing here, we're going to basically distribute your exponent in. So an a divided by a b to the nth power, the a gets the nth power and also the b gets the nth power. So in number 5, I distribute this 4 into everything. So the 3 gets the 4th power, the x gets the 4th power, and the y in my denominator gets the 4th power. Now the only thing that I can do here is a 3 to the 4th power, and you can use your calculator on that. That would be 3, and then you use the caret button to the 4th power, which is going to be an 81. So I have an 81 x to the 4th over y to the 4th. And that's my answer. There's no negative exponents there, so I don't have to worry about that. And now we're going to do number 6. So I have a 6 cubed and a 5 squared raised to the cubed, or to the 3rd power. I'm going to multiply those exponents. So a 2 times a 3 is a 6. And so I do a 6 cubed, which is a 216, over a 5 to the 6th power, which is a 15,625. And that's it. Now I know that that cannot be reduced because 6 and 5 squared, which is 25, don't share any common factors. So it's always best to simplify from the start if you can. And since I could not simplify the 6 over the 5 squared, then I won't be able to simplify my final answer. And we'll get to simplifying a little bit later. But moving on to number 7, this one's a little bit tricky. So I have a negative being raised to the negative second power. So whenever you have a negative number being raised to an even exponent, that negative is going to become a positive. So right away, the negative can be canceled out. It's going to become a positive. So now, there's multiple ways that you can do this problem. I'm going to show you both ways. I'm going to make everything inside of my parentheses get that negative second power. And x to the fifth to the negative second, we multiply those exponents there. Sorry, that should be a negative 10th. And a y to the fourth to the negative second, we multiply those exponents. Now everything has a negative exponent on it, so essentially the 5 to the negative seconds coming up, the y to the negative eighths coming up, so I have a 5 to the positive second, y to the positive eighth. And then all over, the 7 to the negative second should go down, the x to the negative 10th should go down. And then now I can simplify these things because I have a 25 is a 5 squared, and a 7 squared is a 49. And this is your answer. Now, there's another way that you can do this. You could also, if you have a negative exponent on the outside of a fraction, I'll actually show you this way in number 8. Because we have a negative exponent on the outside of a fraction, what you could do right away is you could flip your numerator and denominator around and turn that negative exponent into a positive exponent. So we could have done that in number 7. We could have flipped the 5y to the fourth and the 7x to the fifth around and changed it into a positive second exponent on the outside, because essentially that's what we're doing here. I'm raising the b to the 7th up, the b to the 4th down to turn this into a positive. It's up to you how you want to do that. Or you could have distributed the negative 5 in and done it that way. It's up to you. But now I'm going to do a b to the 7th to the 5th, which I multiply the exponents there, over a b to the 4th to the 5th, multiply the exponents there. And so now I'm going to subtract the exponents. Since the b in the numerator has the larger exponent, my final answer is going to have the b in the numerator. And a 35 minus a 20 gives me a b to the 15th power. Number 9, it's up to you. You can either flip this around to make this a positive exponent, or you can distribute that negative 4 in right away. I'll show you the way that I did in number 7. So distributing that negative 4 in, I get a 2 to the negative 4th power, m to the negative 16th power because I multiply those exponents, and m to the negative 8th power. So now I'm going to change everything into positive exponents. So I'm going to send the m to the negative 8th power up, and I'm going to send the 2 to the negative 4th and the m to the negative 16th power down, and I change it all into positive exponents. All right. I can simplify an m to the 8th power divided by an m to the 16th power. Since the exponent of 16 is larger than the exponent of 8, that means my m is going to wind up in the denominator, which means I'm going to have just a 1 left in the numerator. A 2 to the 4th power is a 16, and I wind up with m to the 16 minus 8th power, which is going to be an 8. All right, and then in number 10, I'll show you how to do number 10 like I did in number 8. So I'm showing you multiple ways each time. So since I have a negative exponent on the outside, I can change that into a positive exponent by flipping my numerator and denominator. And if you don't like this way, then don't use it. It's up to you. Okay, now I'm going to distribute that 3 in. So I have an a to the 2 to the 3rd power, which gives me an a to the 6th power, all over an a to the 4 to the 3rd power, which gives me a 12th power. and an a to the first to the third power gives me an a to the third power. Now I'm going to use something that I learned in the last lesson, and I'm going to multiply the a to the 12th times the a to the third by adding my exponents there. And then now I'm going to divide the a's, and since my larger exponent lies in the denominator, and my a is going to stay in the denominator, I'm going to have a 1 left in my numerator, and I take my larger minus my smaller exponent, so a 15 minus a 6 gives me an a to the 9th power in the denominator. All right, and that brings us to the last of level 1. So you learned about exponents of 0, you learned about negative exponents, you learned about multiplying powers with the same base and dividing powers with the same base, and you learned about what happens if we have things in parentheses being raised to an exponent. So that was a lot of information, but now you're going to start to practice that.